Hey folks, this is the video to help you with the trig unit extension problem. So we want to write two different equations to model this blue graph right here, and we are told that each of those tick marks is worth 1/8 of a unit. So let's think about what we need to identify. We need to identify the amplitude, and we can do that by figuring out what is that distance right there. And notice that is the same distance as that negative distance right there. Our axis of symmetry is running down the x-axis, which means this graph has not been shifted up or down at all, which is nice. That makes our life a little easier. So what are we going to do? Well, let's think about how many tick marks we have here. We've got 1, 2, 3, 4 tick marks, and each tick mark is worth 1/8 of a unit. So we've got 4 times 1/8 of a unit is 4/8 of a unit, which is 1/2. So I know the amplitude is 1/2 right here. Now we also need to determine the period of this function t. So how do we do that? Well, remember our school is peak to peak, so you could look at that distance right there. Not how I prefer to do it. I prefer to look at zeros instead. So remember, the period is how long it takes to complete one full cycle. So I'm going to trace in a period here on the graph. I'm going to go from 0 up, down, past another 0, and back up. So notice I've gone through 3 zeros here, and that is showing me one full period. And now we can count those tick marks to determine how long our period actually was. So just like before, I'm just going to count the number of tick marks. If I'm starting here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 tick marks there, and each tick mark is 1/8 of a unit. That means I've gone a distance, a total distance there of 1 unit, because I had 8 tick marks times 1/8 of a unit for each tick mark gives me 1 for the length of my period, 1 unit long. Now what should we do with that? Because remember, we're going to try and write an equation here. But we have a modified period. So normally what we do is, if we're dealing with some equation, let's say y equals, that looks like a 4, let's redo that. Let's say y, oh my goodness, y equals a times the sine of bx. I'm just going to write as plus c like that. No term at the end, like no plus d, because my graph has not been shifted up or down. But remember that we need to figure out, what am I saying? We want to figure out that coefficient b. And we know that the normal period of the sine graph, the normal period of sine is 2 pi. And what do we normally do? Well, we take 2 pi and we divide it by that coefficient to determine what the modified period is. Well, our modified period is 1. And so we can solve this equation for b by multiplying by b on both sides. So that's going to multiply up, and we will get 2 pi equals b, which means our coefficient there was actually 2 pi. And that makes sense, because that means we're taking 2 pi divided by 2 pi to get our period of 1. Remember, that's just normally what we do to find our period. If I had y equals sine of 4x, I would take 2 pi and divide it by 4 to determine that the period was pi over 2. It's the same exact thing here, except we are working backwards. So I can kind of start to write my equation now, but I still need to figure out my phase shift. Well, let's first think of what are the graphs we're trying to write the equation for. We want to write one equation that is going to give us a positive sine graph, and then we want another one that's going to give us a negative cosine graph. So let's do the sine first. Think about what we know about a sine graph. A sine graph starts at the y value of 0 and then runs through its cycle like that, going up first. So if it's positive, we need to find a spot here where our sine graph starts at 0. So where does it have a 0? And then where does it go positive from there? It needs to go positive to the right. So if I pick this 0 right here, and picture this graph right here going up like that, that is a sine graph. It's starting with a 0, and it is moving up to the right. And how far over is that from the origin? Well, I've gone 1, 2, 3 tick marks to the left. And remember that each tick mark is 1/8, so I've gone 3/8 to the left. And so I can write this equation as y equals my amplitude, which we found to be 1/2, times the sine of b, my coefficient, we found to be 2 pi. And notice I'm going to write it factored as x, and then my phase shift was 3/8 to the left, so that's going to be plus 3/8. And notice, when I have it factored like that, I can actually just add the 3/8, the shift to the left that I wanted. That is the beauty of having it factored like that, and if you were to graph this, you would end up with something that looked exactly like this. So now that we have our sine graph taken care of, let's go ahead and write the equation of our cosine graph. And remember, we want this to be a negative cosine, so we're going to need the same amplitude, but this time we need the negative 1/2 to make it a negative cosine. So negative 1/2 cosine of, the period will be exactly the same. So all we need to do is figure out an appropriate phase shift, and we have our next equation. So we need to look up here, and we need to think about what we're trying to find. We need a negative cosine graph, which if you picture cosine, it normally looks like that, but we want a negative cosine graph, so we need to be starting at our minimum value and then going up like that. That will be a negative cosine graph. So just find a spot where this graph starts at a negative value and then go from there. Let's choose this right there. That starts negative and then goes up and runs through a normal negative cosine graph there. What is that value? Well, 1, 2, 3/8, this time to the right. And so we can write this equation as x minus 3/8. And we are done. Are those the only equations we could write? No, we could write infinitely many more, but those will absolutely do it. And in terms of explaining this to me, if you can show me this work that I've shown you here, and then give me a brief explanation like I did with my words, but briefly explain to me how you know the phase shift and how you know where to start that graph. Like we knew negative cosine needed to start at its minimum value. Well, see what you can show me.